So today we're still going to be doing application problems with exponential functions, but today instead of like figuring out what a is, like the amount after a certain amount of time, today we're going to figure out the time it takes to get to that amount. So it's a little bit different, but we're going to use the same formulas. So on example 1a, you invest $3,000 into an account with 5% annual interest compounded continuously. So the continuously compounded interest formula is A equals P E to the RT. So jot that down, please. And the question is, how long will it take your money to double? So what we're looking for today is always going to be the T. That's what we're going to want to know. So what is this 3,000? Is it A, P, or R? P. Good. That's the initial investment always. All right. So if the interest rate is 5%, what is that as a decimal? 0.05. Yeah, good. And then A is the amount after time passes. And so if we want this 3,000 to double, what do we want A to be? 6,000. So we want the 3,000 to double. So A is 6,000. All right, so I'm going to take those three things. I'm going to put them into my formula. And then we're going to solve this equation for t. And so it's an exponential equation. So we want to get what I highlighted there in blue. We want to get that by itself first, or isolate that. So how would I do that? Yes. So our first step on all of these is to divide. So whatever is in front of the e, we're going to divide by it. Oh, let me fix that. I don't know why I did that. It's a mistake. All right, so 6,000 divided by 3,000 is 2. That shouldn't be a surprise because we wanted it to double. When we divide it, we should get 2. All right. What we're going to do is write in logarithmic form. And if the base is e, what kind of log is it? It's a natural log. So base e, I'm writing kind of small, is going to be ln, or natural log. All right, so I'm going to draw an arrow over here. All right, and so a lot of times this is written the opposite order, like the e is on the left and the 2 is on the right. But since it's base e, we're going to do the natural log. All right, and what should I write next? It's either going to be 2 or it's going to be 0.05t. Would it help if we rewrote it like e to the 0.05t equals 2? Yeah, so the next thing, if you did the loop, the next thing would be 2. I'm squeezing this. And that should be equal to 0.05t. So logarithm always equals the exponent. So that's the way it ends up being. Because the base was e, we did natural log. Okay, now we can figure out the natural log of 2 in the calculator. Now this was a lesson that I had left early that day, and you guys kind of watched the video to learn it, so I wasn't here to see how well you felt about it. But the natural log button is right beside the 4. So we would do the natural log of 2. All right, and we just jot down that decimal. All right, and then we want to solve that for t. So what should I do with this 0.05 divided by O? All right, so it looks like it's going to be 13.9 years for their money to double. Oh, let me move it where you can see that. Right, and that's technically with this situation at 5% interest, that would be how long it would take $3 to double, or $1, or $1 million. So, anytime we want it to double for this situation, is going to work out similarly. All right, let's look at one more, and then you guys are going to do the last two on your own. So for B, we have a culture contains 35 bacteria that doubles every minute. How long will it take the culture to contain 4,500 bacteria? So this is a different question. We would look to see how long it would take this amount of money to double. This is totally different. So this time, like every minute, the number of bacteria is double. So that's going to be this formula. A equals P, and then 2 raised to the T. So what is 35 going to be? Initial P, yeah, it's going to be P. All right, what about 4,500? What's it going to be? It's going to be A. And T is what we're looking for. We're looking for the time that it takes for 35 bacteria to turn into 4,500 bacteria. All right, so I'm going to plug those into the formula. And just like the last problem, our first step is to divide. So we're going to divide by that 35. All right, and then we're going to write in logarithmic form again. If it helps you to switch sides, you can go ahead and do that. It's no big deal. You just flip them over if it makes it make more sense to you. All right, so this is going to be log base 2 of 128.571 equals t. Now, on your test on Friday, there's a lot of times that you're going to need to be able to get the log base in the calculator. Do you guys remember? Good. Alpha, window, 5. All right, I'll take that. That pretty much looks like 7 years. No, not years. Just kidding. 7 minutes. So the next two are very similar. And this is all we're doing today for this lesson. Just you guys are just doing these two. I'm going to give you the answers. And when you're done, make sure your name's on it. There's not a place for your name. Make sure your name's on it and turn it in when you get these answers. And then I'll give you the review that we're going to work on for 2 days. And if you need me to help you, please let me know.